Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Recommender Systems. Our guest speaker today are Mr. Kant Kishore Sharma, Senior Associate Business Consulting at Sapien Nitro, and Mr. Siva Kumar Kalyanasundaram, Director of Technology at Sapien Nitro. Mr. Kant is working as Senior Associate Business Consulting at Sapien Nitro and has over 8 years of experience in the IT industry. He has worked on different projects related to telecom, banking, travel, and e-commerce. For the current project, Mr. Kant is working on designing a vacation recommender system for one of the major cruise liner. A second speaker, Mr. Siva Kumar, is working in Sapien Nitro as a Director of Technology and has over 20 years of experience in the IT industry. Mr. Siva Kumar comes with rich experience in software development, including development of products, frameworks, and tools in leading companies. At Sapien Nitro, Mr. Siva Kumar has led several projects in e-commerce ticketing and is currently working on a cruise booking engine, including a vacation recommender system for a major cruise liner. So without further delay, I introduce you all to our guest speakers. Over to you, Mr. Kant.
Thank you, Mohini. And via this, I also want to thank you, TechGig and Mohini, for helping us arrange this session. As Mohini has already introduced us to you, I would directly go to the presentation of the today. Hopefully everyone is able to see the screen. Mohini, is it clear? So Mohini, are you able to see the screen?
Yeah, we can see the screen. It's very much clear. You can start.
Okay, cool. I'll start. Thank you everyone for joining this session. As you know, today's session is on recommender systems. Before starting, I'll take all of you through a very general life scenario where I will try to explain that how a recommender system is playing a role in our daily life. Let us assume that you walk up to a restaurant and then maybe you are there for the first time and you go through the menu, or maybe you are there for the second time but you don't want to consume what you had already. So what you do is you go through the menu and take some time, and then waiter shows up and asks, okay, what's the order, sir? And then you say that, okay, give us some time. And even after some time, you are still there. You don't have your mind made what you want to have today. So you end up asking one question: what you would recommend today? So in that case, you give some preferences to the waiter. Okay, I like spicy, or I like maybe. What we will be discussing on in
Your voice is going off. Can you please check the connections?
any of these, because of the timelines and the vastness of this topic. Let's move on.
Mr. Kant, I would like to interrupt you. Just a second. Your voice went completely off for a while in between, so can you start it all over again, because your voice went off completely. I don't know what happened, but we could not hear you.
Is it okay now?
Yeah, it's good now. You can start.
Okay. Uh, so I was. So let me first again go through the agenda. So today's agenda will be what are the recommender systems and why we need them. We will also see some examples, and we will discuss the tools and techniques for the recommender systems, and then we will also see what are the factors that generally impact the design when we are thinking of a recommender system, and then we will also see that how we can evaluate any recommender system that we are designing or that we are implementing. And we will also go through the future of the recommender systems. In general, what is the recommender system? In a very simplest terms, I can say that anything that can recommend, any system that can recommend can be called as a recommender systems. And what is the general item that I can request for a recommendation? It can be a news, it can be books, it can be movies or music or vacations and cars. If you notice that what I have done is I have listed them in the way of the involvement of the products, means how much money or the time you are spending on these articles. Like if you are surfing through the news on the web, it might not cost you anything. But if you're buying books or music or movies, that may cost you somewhere around, you can say from $10 to $50. But when it comes to vacations or cars, it may cost you from $1,000 to even up to $100,000. So depending upon the extent of involvement in the product, the different recommender systems are there in the industry, and we will talk about those in the further slides. Digging a little bit deeper into the recommender systems definition, these are the techniques and the tools suggesting items of use to a user. So in general, there are two types of recommender systems. One is personalized, where we request explicit or the implicit needs of the user from them, and then we will try to recommend the items or the products to them. And the non-personalized, where we don't seek any information from them, we will just recommend them maybe on the basis of top ratings, or we might be showing the same stuff to multiple users who are seeing the web at the same time, or it may be at a different time. So why do we do this? It means why do we do non-personalized? Because we don't have a precise information about what type of user is logged in or what type of user we are dealing with. Or going back to the restaurant example that I gave initially, sometimes we see that the featured item on the restaurant menu, that this is our today's featured item, that can be considered as a non-personalized item or non-personalized recommendation from the chef to the people who are, or to the guests who are visiting their restaurant. Okay. So moving on to why there is a need of recommender system. One of the famous quotes from Mitchell Kapoor, getting information off of the internet is like taking it in from the fire hydrant. This definitely tells us that there is a lot of information on the web, and it is really challenging, and because we need to search through all these available information, and then try to get the information that we need. So to overcome the challenge of this information overload, we need some system that can save our time and give us the exact information that we need. The second need is a user experience. User might not be having so much of time to invest, to dig through all this information. It saves time, it saves the user experience, productivity, and one of the major requirement of the recommender system is the revenues. There's a study or the survey by a company called Practical E-commerce. As per them, if there is a recommender system in your system, that can increase your sales from 8 to 12%. And because if you have recommender systems in your system, you can potentially convert your browsers to buyers, and you can also identify the opportunities for cross-sell and upsell. So recommender system help in addressing this information overload problem by retrieving the exact information that is required by the user. And this may be on the basis of his preference or maybe on the his similar users' preferences. Let's take a look at some of the examples for personalized recommendation system from Amazon. So if you can see, the item that the user viewed was one camera that was Nikon D7000, but it also showed the other cameras that the customer who viewed this item has also viewed these items or taken interest into these. So this is a personalized recommendation recommendation on the basis of user history, user's browsing history. And if we take a look at the second one, which is non-personalized, it is showing us what other customers are looking at right now. Okay. So these can be similar for multiple users, or you can also see the top products in some from some category, maybe top 5 books or top 5 electronic gadgets. Another example is from Facebook. You get friends suggestions every time when you log into Facebook at the left hand side, sorry, at the right hand side. And this is generally called people you may know, and the factors that generally play part in getting that list is maybe your geographical location from where you are, your school or your company where you work, or maybe mutual friends, or the tagging that you generally do on your photos. So these are the different features that help to create the association between two users and helping them to suggest possible or probable friends. I would also like to take you through one of the very interesting site for recommendation. The site is wantful.com, and that site helps us in selecting gifts, because this is a very challenging thing when we really want to select a gift for someone. We really ask for recommendations from a friend that, okay, I have to gift someone, so please suggest me something. This is a very nice site for that. Oh. I don't know what happened with this site. It was working. Okay, let's move on without the example of this Wantful. Generally what it does is it asks you certain questions that, okay, you want to create a gift for your friend who for the occasion of his birthday, and what is the money you want to spend, maybe $100 or $50. When you get time, you can go through this site. Definitely you will love it. And then it asks you the question, what type of person this guy is. Is he very arranged? Does he likes cooking? And when it comes to food, does he loves to eat, or he lives to eat? Or a certain psychographic question where he wants to certain sites. Okay, let me try. I think it is coming up again. Yeah, it came up. Hey, Moini, are you able to see the website that I'm presenting right now? Okay, so here you can see the example that I'm trying to create a birth, and he's my friend, and I just want to spend a gift for Kant and $100. So here I would like to give what kind of objects he has. I can select the range or decrease or increase the range. And what would Kant like to do when he wants to spend his free time, maybe outdoors, cities, and shopping. And then where he wants to live, maybe an apartment, you can say, or you can also select multiple, maybe a tent. When it comes to food, Kant lives to eat or eats to live. When it comes to cooking, he loves it. How organized? I can say I'm very organized. So then that is it. The inputs that the system wanted from the user. I don't know why the system is taking time to. Generally, what it does, it gives you the options here that can be within the selected range and that suits the inputs that you have provided. So moving back to the presentation. So yeah. So there are multiple examples that are currently available on the web and that are really working towards customer to save customer time and really helping them in recommending or selecting some of the products. Let's move on to the data acquisition or the techniques that we generally use when we try to think of a recommended system for implementation. The first thing is the data, that what type of data is with us and how we are going to recommend something from the data. So the first type of data that I can talk is explicit data, which is customer rating can be one of the data that is explicitly available in the system. Feedback. Feedback can be thought of in two ways, like likes and dislikes, which is a very binary type of feedback. Or it can be textual feedback, which is really hard to use as feature, but if you really wanted to use the textual feedback, you really need to structure that feedback. Generally, a normal feedback is unstructured. Demographics. Demographics can be statistical data of the user, maybe age, gender, employment status, and the location. Psychographics. Psychographics is one of the examples that we saw on wantful.com, that we are trying to see the personality of the person or the attitude, the interest, or the lifestyle. Maybe asking the question, as they said, do you like to cook, or what do you do in your free time? So this is the type of psychographic data that we generally ask from the user. Purchase history. Ephemeral needs is also one of the explicit data. Ephemeral needs is a need for the moment. You might need something that is explicitly you need for that very particular time. Implicit purchase history or the browse history, we are calling this as implicit because the guest doesn't know that someone is capturing that data for me for recommendation or some other purpose. And then another thing can be product information, product taxonomy, product attributes, descriptions, or even the knowledge base that is existing in your system. Let's directly jump to the recommendation generation techniques. First and the most popular technique in the world is collaborative filtering. Here what we do is we try to find a set of users who has very similar interests than our target user. And then we try to recommend the products from the set of that we found as a collaborative users, the users that have a similar interest set. So as we say, this is a method to find a subset of the users who have similar tastes and preferences from the target user, for which we are generating the recommendation, and then using this subset for offering recommendations. So you can see the example that is available there. Customers who bought this item. So in this one, I had selected, I think it was Nikon, some DSLR camera, and then it suggested the compatible lenses with it and some UV filter protection. So customer who bought this also bought this. This is a type of collaborative filtering technique example. So when we talk about collaborative filtering, the basic assumptions that we take is that the user with a similar interest have common preferences. Let's say guest A or user A and user B are adventurous in nature. Then if the guest B or any collaborative set of adventurous people liked or did, let's say paragliding or skydiving, then it means that our target user, which is user A, will also like it, and we will recommend that paragliding or skydiving to him. And the second assumption is there should be a sufficiently large number of user preferences available in the system for which we are going to build this recommendation system. Otherwise, we won't be able to create the collaborative user set. Okay. So moving on to, again, how the general or the basic algorithm works. We select a target group, target user who is requesting the recommendation, and then we create the set of collaborative users. So how do we do it? We can do similarity metrics to find the collaborative users for this target users. That can be an offline process, and there are different algorithms available, or the two mathematical formulas available, like Euclidean distance or cosine similarity calculation, or maybe Pearson correlation coefficient. There are multiple ways there you can calculate the similarity between two users. And then you can offer the recommendation of the products as liked by collaborative users or as used by collaborative users. A simple prediction function that is shown here is, let us say we want to calculate the prediction for user A for an item J. We will try to find the similarity of all the collaborative users. So number of K is a set number of collaborative users, and sim AI is a collaborative user set for similarity with this user, for the target user with the collaborative set user, and we are multiplying it with the rating difference for any item J, for the item J, for that particular rating by the user and the average rating of the collaborative user. We will sum that up and multiply this with a modulation factor and add it up with the average rating of our target user, which will give us the prediction function or the prediction rating for any particular item. Let's take another example of a collaborative filtering algorithm. This is a little bit different than what we saw earlier. This is called as item-to-item collaborative filtering algorithm rather than user-to-user. So what we are doing here, let us say there is a customer who purchased a product, let's say I1, and let's say it's a camera, and he also purchased another product, I2. We will try to get the similarity between the product I1 and I2, and then we will offline create the pairs of each product, and then we will see if any customer purchases, if that customer purchases any other product other than I1 and I2, we will see what are the similar distance products. Let's say here we find the similarity as X. So we will try to see for each product what are the what are the other products that are at distance X, and we will try to suggest those products as recommendations. This is the algorithm that Amazon.com uses. Moving on to the problems that we generally face with collaborative filtering is a cold start. Cold start is the problem that we already discussed, that we need enough users in the system. It was a basic assumption initially made that we have ample set of users so that we can collaborative sets for each target user. Sparsity is another problem, because when we make clusters or the groups, we really find there are a lot of spaces, empty spaces in between, where we are, where it is really hard to recommend anything to the guests. First rater is another problem, where we can say we cannot recommend anything because it has never been rated. It's a new entry in the system, or it can be a product which is only specific to certain users. Our popularity bias. We tend to recommend a product which is very frequently rated or very frequently used. So we tend to over-recommend that product. So there is a less room for unique people with a unique interest. So there are different examples of collaborative filtering recommender systems. Ringo is one of them. Ringo is a music recommender system that used to tell you all the artists that you can enjoy. It can also use to predict what are the albums of the artists that you will hate, or you can also see the personalized reviews from the people with a similar taste. Ringo became Firefly, and later it was bought by Microsoft. GroupLens is another research group that has created multiple recommender systems. TechLens is one of that, where you can find recommendations on technical articles. There's another one, Movie Lens, which is again created by GroupLens. you can find the recommendations for the movies. Let's move on to the second type of recommendation generation technique. That's the content-based systems. Here we recommend only those products or the products that are similar to the products that user has purchased in the past or liked in the past. That's one. Or we can also say recommendations are based on the information of the content rather than other users' opinion. So we create user profiles to describe the type of the items that user might like. So we can say that we have a user profile who likes sci-fi, action, comedy, and then we will try to match these features of the user profile with the features of the product. Okay. Keyword-based search is also a type of content-based system. There is an example of Letizia, which was an extension of the browser. What it does is it tracks the user behavior when user is visiting the websites, and then it tries to create a strategy, keyword-based strategy, and then directs you, which should or make a recommendation to you or multiple recommendations that what should be the other sites that you might like. IMDb is one of the content-based systems where it tells you or recommends you on the basis of genres you generally like in movies. Last of them, there's a tool called Scrobbler, which also helps you with the music recommendation, but how it does is you install it on your machine, and then it learns that what are the music that you're listening on your computer, and then on the basis of genre and the artist, it tries to recommend you some new songs or the new albums and artists. So there are some advantages over collaborative filtering when we talk about content-based systems, because we don't need other users' opinion, so we don't need data for other users. So there's no cold start or sparsity problem here. And we can also recommend data to the unique people with a unique taste, because if we have the user profile of a unique person, we also, if we have a similar product, we can directly match it and show it to the user. And then we can recommend any new item or a very unpopular item, so there is no frustrator problem that we saw initially in collaborative filtering. And the last one that I really like is that you can provide explanations for the recommendations, that why we have recommended this product to you. I have seen a lot of times in Amazon also that why recommended. If you click over it, it hovers a modal and it tells you, okay, because you selected, or let's talk in terms of a movie, let's say you hover over a movie and you say that why you recommended me this movie, I can say, okay, because you liked comedy, romance, and action, or this movie has all these genres of features in it, so that's why I have recommended it. So what it does generally is increases the trust of the users in the recommendation system, in the recommended system. So we need that, so that more and more people use our recommended system and think it as a genuine system who is really interested in recommending good quality stuff to you. But there are some limitations in content-based system. The basic one is data should be in structured format. We should be having all the metadata associated, all the features properly listed. If you have a music site, it was a challenge initially for some of the music sites that if you cannot read the content of the file, if we talk about music or a video, all you have to do is you have to label all the files with the proper genre, artists, albums, and all the features that you can input, so that you can really filter the feature as per the user's need. And another limitation is in your system there might be very quality judgment of the ratings by other users, but you cannot use it because it's designed like that. The next technique that I would like to talk here is data mining. Data mining is very vast, so out of all the different techniques like association rule mining or classification or clustering, I have just picked association rule mining and clustering for today's discussion. So association rule mining is really focuses on finding the rules, and then we will predict the occurrence of the item on the basis of how other items were present in the transactions. To really understand the data mining part, I would like to introduce few terms before I can talk how this works. So K items, let's say I is our inventory where we have multiple items from I1 to IN, and then we have a subset X with K items in it. So that subset with the K items in it can be called as a K item set. Then we have a support. For any transaction, we call support is the probability of that transaction occurring. Let us assume here X is bread and Y is butter, to be very simple. What is the probability that when a guest or a user buys bread, he also buys butter? Okay, so this is called support. So probability of occurring of both the transactions together, or seeing both the items together in a transaction. The second term that I would like to introduce here is confidence. So confidence is a conditional probability of Y occurring, giving the condition that X is also occurring. So which is the probability of X and Y occurring together over the probability of only X, all the X's that occurred in the transaction set. Okay, so then we calculate the frequent item sets. So for frequent item sets, we first define a minimum support. We know that support is the probability of having X and Y together in a transaction. So we define it. When I say we, it means the admin defines it maybe is at 50%. My 50% of the transactions in the transaction set should have support equal to 50%. If that is happening, then all those K item sets, we will call that as frequent item sets. Given all these facts, this is the process how we use association rule mining. We will find all the frequent item sets. How we do that? If you directly jump onto the last part of the slide, there's a priori algorithm, which works on the principle that if there is an item set that is frequent, all the subsets will be frequent. Then what we do with the frequent item set, we generate all the rules from those frequent sets that we discovered, and then we reduce the set of rules to the ones that are meeting minimum user specified confidence. Again, as we initially defined the support, here we are also again defining the confidence. What is the minimum confidence that we would like to have in a transaction set? Then we can say, okay, this is what we can recommend. Okay, giving an example of a system that works on ARM is a Surflen. Actually, Surflen is a system that works on mining the navigation history of the recommendation. And what it does is it tracks the user behavior on the web and uses the association rules to extract the hidden relationship between the navigation history. The relationship can be between the URLs that are read together by the users, and the relationship can be between the set of the users who read the same set of web pages. So here we are seeing in the first part of the example, the relationship between the URLs that are read together is a pure ARM type of example. But the second part, where relationship between the set of users who read the same type of web pages, it's more of a collaborative. So here we are seeing, in the second example, we are seeing a concept which is also called as hybrid recommender systems. So hybrid recommender systems where we use multiple techniques. Maybe some part of the recommender system is using content-based and some part is maybe collaborative. The other one of the topics that I want to discuss from data mining is clustering. So clustering is making groups of like similar items. So how we calculate the similarity, as I told initially, that we can have Euclidean, there are multiple distance metrics that we can use to find clustering, to find the similarity between two groups. And after finding the similarities, we will try to create groups where intra-cluster differences are minimal and the inter-cluster differences are maximum. So there are different algorithms that are available in the market or in the research area that can help you do the clustering. One is partition algorithm, other one is hierarchical. There are others also, but these are the two majors. So partition divides into non-overlapping clusters. with exactly each data item in exactly only one cluster. Hierarchical algorithms successfully cluster items within hierarchy. So you kind of produce nested clusters. An example is the Google News that also use clustering for logically grouping the news rather than showing you the raw listing of the news. So it used the cluster mechanism. Then the next one that I would like to discuss is constraint-based recommender system. This is the type of the recommender system that we are currently working on for one of our cruise liner. So here, what do we do is we request the data from the guest first. So we get all the customer requirements with item features, maybe in term explicitly or maybe implicitly asking them maybe what are your interests, and then we can map those interests with our products that we have internally in the database. And then our recommender system has already knowledge bases, means products, and then we have a mapping for those products with the interest or the explicit or implicit inputs that we get from the customer. So there are two major types of variables that generally play a role in a constraint-based recommender system. One is customer properties, like let's say I'm requesting the interest, what is your time and budget, means for how long you want to go or when you want to go for your vacation. From where you want to depart is also one of the important questions that I can ask. You are in what is your geographical location? You want to depart from India, or you are in some other location of the world. And accommodation and activities preference. What type of accommodation you need? You need a very basic accommodation, or you need a very luxurious accommodation. And activities preference. You want to do something when you go there, or you just want to do sightseeing and you do stuff on your own. So these are the questions that I get generally asked from the customer in constraint-based. And then we have product properties also, destination dates, ships. So these are the properties that all the products that we have internally in the knowledge-based system. So I can say, let's say I want to go to Alaska. Alaska is my destination, and what are the dates when my cruise or anything that goes to Alaska. So it should not be winter because nothing happens in winter in Alaska. So all the dates will be in summer. Then what are the ships that are going to there? Then what are the ports of call? What are the activities that are offered on the ports of call or even on the ship, because the ship also offers you a number of activities. Then constraints. What are the constraints that are already there in the ship that we say that these are not compatible things? We can say a person might want a very luxurious accommodation, and that is not available in certain ships. So if I can say that if the ship, if the accommodation is luxurious, then this ship should not be ABC, the ship name. Or maybe if a person says, I want to do some adventurous activities or relaxing activities, and these type of activities are not available on a certain port, then I would say, okay, no, this is a constraint in the system that I should take care of. Then we will create some filter conditions that, okay, if the customer input is weekend vacation, then I cannot consider any vacation which is greater than 10 days, or even a shorter duration vacation preference cannot be, we cannot recommend any longer vacation. Or lower budget is incompatible with the suites on the ship, because suites in the ship can cost you up to $17,000 for 7 days per person. So these are the incompatible filter conditions. Then after applying all these conditions, we are left with the products that we can really suggest with the users. And what we are doing currently in our system is we are doing a weighted constraints. We are not saying clearly that this is a no or this is a yes for recommendation. We weight them. Then after weighting, we get the highest weightage for the products. And initially, how we are getting the destinations from the initially when customer gives us inputs like interest, maybe psychographic or the demographics input from his choice, we create a vectors out of that and map it to the available destinations, and then we add up those to create weights for the system, and then we create we sort them to give the final recommendation, maybe top 3 recommendations or top 3 vacations for the guest. These were the techniques that are available, or the most popular techniques that are available for recommender systems. One of the tools that I want to discuss here is it's a very young tool. The name is Apache Mahout. This is capable of executing complex data and data mining algorithms, and also collaborative filtering. It currently works. It's supported on Hadoop, Apache Hadoop, which is a distributed large dataset system. But it can also support single node, smaller systems, or even a non-Hadoop clustered systems. The features that generally Hadoop offers is, Mahout offers is collaborative filtering, and that we saw, content-based recommendations, data mining algorithms, clustering, and classification. All these are generally, and this is currently this Apache Mahout don't have any kind of interface, but it's a Java-based libraries that you can call and use to make recommendations. Moving on to our next topic of the session is design. What are the factors that impact the design? The first one is the data model, because this is the main thing, as I initially talked, that you must be having some data set that you can think of how you are going to generate recommendations out of it. Is your data unstructured, or your data is structured or partial? So if data is unstructured, you might have to make some efforts to make it structured so that you can make some recommendation, or you can do even clustering on it so that you can get the similarities on certain features, right? So because in both the type of systems, even if it is a collaborative or it is a content-based, you have to create the similarities between the two types of entities. The second one that you should take care of is user profile. Who are the users and what are their preferences? Are they just customers who are just buying, or they are people who are just seeking the news or technical? Because based on your user profile, you can also think of the utility of the recommender system. Is it going to impact your revenues or not? And then algorithms. Which algorithm or the method you should use? Depending upon the structured or unstructured data or type of the users, if you have a lot of user data in your system, then obviously you can go for a collaborative set of user algorithms. If you don't have user type of user data, but you have a product data and you can exploit that data for recommendation, and definitely you have another set of algorithms to use. What tools to use? You want to use a custom code or a specific tool, like the different tools that are available in the market. What is the architecture? How it will be implemented? What are the touch points, external points? How you will be interacting and integrating with the existing system? Because your recommender system is a subset of the complete system. So it has to interact, get the data, existing data, and it has to even post that data to an existing, because you're not going to make a new site for your recommendation area. So for your recommendation, you might be just showing the recommendation in an existing area. So you have to kind of think that which technology suits best as per the current architecture of the application. As we talk of design, again coming back to the data, the source of knowledge and the probable approach is probably the thing that you need to think. This diagram really shows us that what kind of data we have and what are the different approaches we can generally take. So if we have context, so context, we haven't talked about context in the whole session yet, but I can talk briefly on context. Context, there are context-aware recommender systems also, which take care of the context also. Context means, let us say I want to go for a movie with my friends or with my family or with my girlfriend. So here the context is different. So again, another example. Summer, I want to go for vacations in summer or in winter. So we have a context of season here. So on the basis of context of seasons, we can say that, okay, your suggestion or recommendation will change on the basis of context. So context can be available as your one of the input. Opinions can be behavior and demographics. So if we have these inputs, then definitely we can go for a collaborative type of recommendation system. If we have opinion, behaviors, demographics, and item features, then we can go for content-based. And if we have demographic requirements, item features, domain knowledge, and contextual knowledge, then we will go for the knowledge-based. Here, when we are going for the knowledge-based, we are missing the behaviors and opinions. If we do have, then we can create a knowledge-based hybrid system that can be collaborative also. Okay. So as we can say that this Facebook and the Twitter, the recommendation that we generally get is collaborative, because we have the context of opinions and behaviors and demographics from these social inputs, social knowledge resources. And content, we saw the examples for content-based, as we saw a lot of examples from IMDb or the music sources. And the knowledge-based, I gave you one example. The Eventful was one of the knowledge-based example. The one that we are creating for our client is also a knowledge-based, which is, because constraint-based is a knowledge-based type of recommender system. Once we think of designing, or once we say that we have to implement or we implemented a system, it also needs evaluation that how our system is doing. So there are different types of evaluation that generally a person can or a team can do. Is offline evaluation, where we try to simulate the user behavior on the pre-collected data set, and then we analyze the recommendations. And this is one of the easiest way to do evaluation, because you don't have to interact with the users. You have all the results with you. You can tweak the system as and when you want. You can change algorithms and all. But the biggest challenge here is, for this type of evaluation, you don't have, you cannot create exact user behavior through offline simulation or automated simulation. So for that, we have to go to the users for studying them and conducting the user studies. So when we do the user studies, we record a set of users and ask them to perform several tasks, and they can interact with the recommender system, and then they can tell us, or we can observe or record their behavior and collect any number of quantitative measures, and we can also see that what kind of task they have completed, what is the accuracy of the task, and how we are doing on recommendations, how recommendations are impacting user behavior. We can observe all those things. And we can also present questionnaires. The other one is online evaluation, when we really try to compare multiple algorithms real time. What we can do is we can implement multiple algorithms, and we can route some of the traffic on one of the server, and then rest of the traffic to a different recommendation engine. And we can see how user behavior is, how recommendations are coming up, whether the users are using the recommendations or not, even noticing it. And how different, then we can compare the two algorithms, and this has happened a lot of times, and then people choose the one that is performing the best. The next one is evaluation. In evaluation, that what kind of possible recommendation you can have. Let's take a look at this small table, but it's a very interesting table. Here we have on x-axis we have recommendations, recommended or not recommended. Let's say an item can be recommended or not recommended. Once it is recommended, it can be liked by a user or not liked by a user. Okay, so any item. So here we will try to calculate the precision from this table. If an item which is recommended by the system and also liked by the user, we can call it as it was a true candidate for the recommendation. We call it a true positive. And if there is an item that is not recommended by the system, but user wanted to see it, it was an item that user really needed, then we will call it a false negative item recommendation, because we wanted it but we didn't show it. Our system did not show it. And the next one is when we recommended it, but user did not like it, he did not wanted it, and then this is false positive. We are showing it, but it's false. And the last is the true negative. We don't want it, we did not show it. So there are three major factors by which we can evaluate the possible recommendations. Precision. So it is a ratio of true positive over the total recommendations that were made by the system. And the true positive rate is a ratio of true positive over the items that user wanted. So we should try to keep precision and true positive rate as high as possible. So if it is we are getting by some system, we are getting it's the highest, then that system is the best. And the false positive rate is the exact opposite of true positive, where we are trying to see how many recommendations we made incorrectly out of the total recommendations that user did not want it. There's another metrics that we can use to find the absolute error. This is the mean absolute error, where we will try to predict the ratings by the system and the ratings given by the user. And then we will try to find the error. We generally try to keep this error as minimum as possible, but that generally doesn't happen. So the highest error, mean absolute error, we are going away from our goal. The last part in evaluation is success of a recommender system. These are the major factors that generally play a role for success of a recommender system, which is prediction accuracy, how accurately we are predicting the data or the recommendations to the user. Coverage. Coverage is one of the very important factor where we say, what is our item space coverage? Means out of the, let's say our system has 100 products. Are we capable of suggesting all the 100 products under different conditions? If not, then what is the reason? And if it is legitimate or is intentional, then it's fine. If it's not, then we need to tweak our algorithms. Then user space coverage, because there can be different types of users on our site. It can be a person who has very unique taste or very common type of user. So can we recommend at least something to a unique user? So that is our user space coverage. So sometimes system might not recommend anything to our unique user due to the low confidence in the recommendations, because there are in most of the recommendation system we also define confidence of the system. Okay, if the confidence is X, then only show this. So if we are not able to recommend anything to a user, what is the accuracy, confidence, and the user space trade-off that we need to decide? That, okay, if the user is unique, let's show him something which is at least this much precise. So we can create kind of a plus minus threshold on our, I would say, general confidence rate. The confidence, again, as I talked, confidence is the trust of the system in recommending something. So how well the system is comfortable or believe that this is a correct recommendation and user will choose it. And the next one is trust. As we talked, confidence was a system's trust. Now trust is a user's trust in the recommendations. Do I like the recommendations that are made to me? If that is not happening, then user might not come back to our site. So sometimes what we do, what systems generally do, they really recommend something that is already liked by user or known to the user, or matches with the user preferences. Even though that is a repetitive recommendation, but it increases the user trust that, okay, at least the system is recommending me what I am liking. And this will generally increase the credibility in the system. Serendipity. How is our system capable of showing the new items or even showing the surprising items where, let's say, system can recommend me a movie where I can say the actor is very good. I like the acting. So how serendipitous are our recommendations? Scalability. Can we increase the system as per our data needs? Because as we grow or move forward in future, we really need to think where the systems are scalable. We need to adopt those algorithms that are free or that are good enough to scale up to maybe larger sets of data, maybe even petabytes of data, without impacting the prediction accuracy, without impacting the performance. Utility is also one of the major success that, let's say I implement a recommender system on my side, and if that is not giving me any profit, means what is a initial thought when I created this recommender system? What was my utility? I wanted to increase my sales. So if it is not happening, then that's not the success of the recommender system. Then privacy, because users generally give you the preferences. So we should maintain the privacy, and is the system is capable of maintaining the privacy? This should not be used somewhere else, because this is becoming a large challenge, because users give you all the preferences and this can be misused over the internet. And the robustness of the system is also required, because sometimes people just test the system, or even by mistake, sometimes systems tend to get wrong inputs, and how the system performs in those conditions. So all those things should be evaluated when we design a recommender system. Coming on to my last slide of the session, future of the recommender systems. What I generally feel, or how I see the recommender system is, when I sit and get a recommendation from any system, I should believe in that. So recommendation system can be implemented in any e-commerce site where you generally transact on a daily basis, or maybe even other areas like IPTVs, recommending you the programs. So I should it should be widely available. Another, the guest or the user should trust on it, so that we can meet the purpose of actual the invention of recommender systems. The second one is the social search. Currently, the search in today's world, the search is one size fits all. Whatever you search and whatever I search, if the keywords are same, I'll generally get the same results. Can we implement the recommender systems for personalization and using collaborative data from the social sites, the social medium, so that I can get very personalized search results that are very much beneficial to me? Because as per one of the survey, 10% of the person's time goes in daily for the incorrect search that we don't need at all. And the last topic is big data topic, because with the invention of big data, and now it's coming and moving slowly into the different systems. Initially, as we talked, information overload is a problem. Having too much of information is just like having no information. So big data is moving to that. Big data is actually that thing, where it's data is stored in flat files, not even in RDBMS. So it's a huge amount of data, like 1,000 terabytes or even 1 million terabytes. So in those cases, how do we need new techniques, data mining techniques or storage techniques, or we can also say, are our current or today's techniques are geared up for the scalability and performance issues for such recommender systems? We need to really retrieve the data from those systems. And so the example that I showed you today was the direction towards that. The Mahout is actually a system that really is working towards that direction. With this, I conclude my presentation, and I think we can take some questions if you have.
I was assigned you some questions, Mr. Kant.
Okay, just give me a minute. Just give me a minute. I'm taking a look at the questions. The first question that I have is, can we say that it's the personalized recommender system is based on artificial intelligence? Yes, we can say that, because the algorithms that we generally use are from the artificial intelligence also. Because if we talk about data mining, we do have classification as one of the data mining popular technique. There we use neural networks as one of the, or creating vectors, or even clustering. Yes, we can say that these are based on artificial intelligence to some extent. And there was another question from the same person, that are these recommender systems learning systems? There was a topic that I initially wanted to cover, but I skipped due to the time. Yes, there are systems that are actually learning on themselves. Means they are learning on the user profile, they are learning on the user preferences, browsing history, and then they store it and try to make a strategy. So yes, most of the, and a lot of recommender systems are learning systems. And I also have another question. Let me go through that. The next question is, are all the data about each customer stored in the client DB, or they mostly retrieved every time from the public DBs, or recalculation several times, like false prediction, etc. As it depends upon the type of the recommender system you have. Sometimes you fetch real time, sometimes you have to cache. If it is as I talked about item to item similarity, and that happens really offline. We calculate the similarity, store it in cache, and accept that on a daily basis. And there are some generally you can say indexed features of all the products that you have. Most of the times these are stored in cache. In our system, as we are using Endeca as our cache, and we directly access those features of the products from there. And some part of it we also calculate in the batch, and then we keep on using that for the full day. There was a question that any two examples of live recommended systems. So Wandful was one of the recommended system, recommender system that is constraint based, and also we can call it a knowledge based. All the recommendations that you get on Amazon are also are collaborative. You get the things that you get on IMDb are content based recommender systems. These are all live recommender systems. As I also told you, SearchLens is one of the, or Letizia, that you can really install on your browser to create a keyword-based strategy for yourself, and then it will guide you to how to. It will recommend you different sites. Let me go through some more. Just give me a minute. What medium and algo in general are used in recommender systems? I don't get this question completely because I don't know what about the medium. But the algos, as we discussed, for collaborative, we have different algos for, because ultimately for in any of these algorithms we need to find the similarities, we need to do grouping, and then we need to decide on the basis of how we are grouping all the data. There are multiple algorithms that are generally inbuilt in the systems that you can use. And I also gave you certain examples while I was showing the presentation. There was a question that is very interesting. What is the scope of research in recommender systems? As I discussed in the last slide, the scope of research, which is which is it will be very kind of innovative if someone can do that. It will be very naive instead. The social search that I initially talked, that how we can collaborate the search so that you can give the search items as per the user need rather than showing me anything that is very non-personalized. And another thing is big data thing, as I already talked in my concluding slide, that the big data, you really need to tune all the algorithms, or we need to really test that are we ready in today's world for the data volcanoes or the enormous amount of data that's coming up in our path. So there's a lot of scope of research in recommender systems, especially in the algorithms that are used in recommender systems. Mohini, I don't think we do have any more questions. There's another question that says, recommender system can or not follow the neural process for the learning systems. I'm not very sure about this question, Vaibhav. I really need to research on that. There's another question. Are most recommendations done on the fly or sent to the customer? No, they are done on the fly. Means as soon as you log in, you start showing them the recommendation on the basis of as per their login. So as I said, that are the basis on their login. So if you don't log in, I don't know your profile. Who are you? If you are logged in if you are just visiting visiting my site as just an anonymous user, what max I can do is I can check your browsing history through cookies and cache if I have that on my server or even on the client side. That is the max thing I can do. Amazon do that. But if you log in, then definitely I have your purchase history, I have your click and browsing history stored in it, and then I can deduce many recommendations through the algorithm that is applicable, and then definitely I can recommend on the fly. But all the recommendations that we make are generally made are real time, not something that we do later. I think there's another question, how data mining algo can help modifying the RS algorithm. As you saw that in every step of every type, the data mining algorithms were used. Whether you have to recommend news or you have to recommend a product or you have to do collaborative filtering between the users, you have to find the similarities between the products. You have to create the vectors, then you have to create the clustering. All the data mining classification, ARM, all these data mining techniques are required in the RS algorithms. Without these data mining techniques, I don't think we can even implement RS. It is generally unsolicited because generally there is a section. If you see the Amazon.com, this is unsolicited, and if you see the Wantful, that the site that I showed you, or the one that we are doing, this is specifically requested by the user. That user initiates that kind of assisted search, that where it is trying to request the help or request the recommendations. So it can be both. It depends upon the design or the requirement, how you want to shake your revenues. There are different tools, or you can also do custom code for all these. The question was, sorry, I forgot to mention the question. There was a question that you said that there knowledge-based recommendation, you have a database of rules. How do you prepare such database? So there are multiple options. There are tools like rules. There are you can build the rules in custom in Java files, or you can also use the rules for Mahout, rules in Mahout, and just directly calling the Java libraries that it offers. So there are different ways to do it. There is a question, but I don't really get it. What are the cross-reference points of recommender system based on learning points? There was another question: is it automated or human intervention needed? Human intervention is only needed from data acquisition perspective, because sometimes we explicitly require the data from the user, or implicitly we also request the data from browsing history or your purchase history. So yes, some part of user intervention is required. Rest of the calculation, all the processing is done automatically.
Well, thanks for the insightful presentation, Mr. Kant. I'm really thankful to you for conducting this webinar. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of the webinar will be available on techgeek.com by evening. Thank you all. Have a great evening.